For notes number 7, we're going to be repracticing how to find missing sides of right triangles using our 3 trig ratios, which are sine, cosine, and tangent. Remember, a ratio just compares 2 things. In this case, the 3 ratios, sine, cosine, and tangent, compare 2 sides of a right triangle. So in our picture, the very first thing we're going to do is locate the reference angle. So 67 degrees, this angle right here is our reference angle. And we're going to be labeling our opposite side. We're going to identify the hypotenuse and then the adjacent side last. However, we're only going to be labeling 2 of those because we never labeled the blank side. So for the opposite, our reference angle, if I go directly across the 67 degrees, there's a variable there. So we're going to label that our O, our opposite. Next, we're going to identify the hypotenuse. Hypotenuse is the longest side of the right triangle, always opposite the 90. So if I look directly across the 90-degree angle, I do see 29 there, so that is a hypotenuse. So we've already labeled the opposite and hypotenuse, so we are finished with labeling because we never labeled the blank side. So if I look at my 3 trig ratios, let's go ahead and identify what sine stands for. It's opposite over hypotenuse. Sine is O over H. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So in my picture, I see that we have O and H labeled, so we're going to be using the sine ratio. So all we're going to do is take this equation and plug in from the picture. If I have to estimate my answer, if I look at my picture, 29, the hypotenuse is the only side given, and so the value of x should be smaller than 29 because the hypotenuse is always the longest side. So if I plug in from my picture, I would have sine, and then again, this symbol right here just represents the reference angle. In this case, it's 67 degrees, and that's equal to the opposite, which is x, and then the hypotenuse, which is 29. Since the right side's a fraction, let's make the left side a fraction by putting a 1 under it, and then we're just going to cross multiply. So 1 times x is x, and then sine of 67 times 29 is just sine of 67 times 29, or I'm going to write 29 times sine of 67. So we're going to be typing this into a calculator. So I'm going to grab my calculator. So 29 times 67 sine equals, and I get approximately 26.7. And that makes sense because it's smaller than 29. Again, make sure that your calculator is on degrees and not radians. For number 2, we're going to do the exact same process in order to find the missing side of this right triangle. So again, we're using our possible 3 trig ratios, which are sine, cosine, and tangent, so SOHCAHTOA. So our reference angle is at 58 degrees right here, so I'm going to label my opposite, hypotenuse, and adjacent. And again, only labeling 2 of those because we never label the blank side. So I'm going to check for the opposite. So directly across the reference angle, you always label your opposite side. And there is a number there. There's a 22 there. So there's my opposite. Next, I'm going to identify the hypotenuse, if it has a variable there or a numerical value. If I look directly across the 90, I notice that it's blank. Therefore, I'm not labeling the hypotenuse because nothing's there. So x would be my adjacent side. Moving on to which trig ratio I'm going to use. Sine is defined as opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So my picture has an O and an A, so I'm going to be using tangent. So when I move on to this next box, just a quick estimate of what my answer should be. If I look at my picture, the only side I have is the 22 units, and x is clearly smaller than that visually, so smaller than 22. So plugging in to my equation here, tangent, and then this symbol again is the reference angle, so it's 58 degrees, and that's equal to opposite, which is 22, adjacent, which is x. Since the right side's a fraction, I'm going to make the left side a fraction by putting a 1 under and cross multiplying. 1 times 22 is 22, and that's equal to x times tangent of 58, which is just x times tangent of 58. One last step to isolate the x, the opposite of multiplying by tangent of 58 would be dividing both sides by tangent of 58. So this is what x is equal to, but I have to type that into a calculator. So I'm going to grab my calculator here, and I'm going to type in 22 divided by 58 tangent equals. and I get approximately 13.7. So again, to type this in, you could read this fraction top to bottom. So 22 divided by 58 tangent equals. For our third picture, I noticed that 37 degrees is our reference angle. So I'm going to start labeling my opposite, hypotenuse, and adjacent. So directly across the 37 degrees would be my opposite side, but there's nothing there. It's completely blank. So I'm going to cross out opposite. Next, I'm going to identify the hypotenuse, which is across the 90, which is my variable here. So my hypotenuse is x. And then lastly, 11 would be my adjacent side. Shifting over to the trig ratio, sine is defined as opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in my picture, I have an A and an H labeled, so this would be cosine. So I'm going to be using this equation in order to find the missing side. So if I look at my picture, I notice that I'm trying to find the hypotenuse, which has to be the longest side of the triangle, and 11 is the only side length given. So I know since I'm finding the hypotenuse, the longest side, my answer should be bigger than 11. So let's plug in from the picture. So I would have cosine, the angle, the reference angle is 37 degrees, and that's equal to adjacent, which is 11, and the hypotenuse, which is x. So to solve this, make the left side a fraction by putting a 1 under and then cross multiply. So 1 times 11 is 11, and that's equal to cosine of 37 times x is just x times cosine of 37. I just write the x in front. It doesn't matter if you write it in front or behind. So there's still one more step to isolate the variable. The opposite of multiplying by cosine of 37 is dividing by cosine of 37. So x is completely isolated. We have to type this in. So to type this in, I would do 11 divided by 37 cosine equals, and I get approximately 13.8 rounded to the nearest tenth. So again, to type this fraction in, just read it top to bottom. 11 divided by 37 cosine equals. For number 4, I noticed that the reference angle is 57 degrees, so I'm going to start labeling my opposite, hypotenuse, adjacent. So directly across the reference angle, that is the opposite side, and there's a number there, 10.8. So I'm going to label that my O, my opposite. Next, I'm going to identify the hypotenuse. So directly across the 90, there is a variable there, so that's my hypotenuse. So O and H are labeled in my picture. So checking on the ratio that I'm going to use, sine is opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. So if I look at my picture, I notice that O and H are labeled, so this is the equation I'm going to be using in order to find the missing side. So I notice that what we're trying to find is the hypotenuse. That has to be the biggest side of the triangle, and 10.8 is the only labeled side, so I know my answer has to be bigger than 10.8. So plugging into the equation, so I would have sine, the reference angle is 57, and that's equal to the opposite, which is 10.8, over the hypotenuse, which is x. So make the left side a fraction by putting a 1 under and cross multiply. So 10.8 times 1 is just 10.8, and that's equal to sine of 57 times x is just sine of 57 times x, or I'm going to write x times sine of 57. One last step to isolate the variable. The opposite of multiplying by sine of 57 would be dividing both sides by sine of 57. So x is isolated. Here's my answer in fraction form, but we're going to type this into a calculator. So I would type in 10.8 divided by 57 sine equals, and I get approximately 12.9 if you round to the nearest tenth, and that is larger than 10.8, so we're good to go. So for this last example, we're actually going to do this 2 different routes. One option is to use the trig ratios, which we're going to do for this first part, and then the second option, because the reference angle is 60 degrees, we could also use our special right triangle pattern, the 30, 60, 90s, because this missing angle is a 30-degree angle using the triangle sum theorem. So that's what we're going to do in part 2, and then compare our answers. They should be identical. So my reference angles is 60 degrees, so I'm going to label my O, H, and my A. Again, only labeling 2 of those. The blank side always is left completely blank. So directly across the 60 degrees is always my opposite side. However, it's blank, so we're not going to label our opposite. Next, I'm going to locate the hypotenuse opposite the 90. So 11 would be my hypotenuse, and then x would be my adjacent. So checking out the trig ratio we're going to use, sine is defined as opposite over hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite adjacent. So because I see an A and an H, we're going to be using the cosine ratio. So here's our equation that we're going to be using. Deciding our estimate, let's see. We're given the hypotenuse, which is 11, and we're trying to find x. So since the hypotenuse has to be the longest side, I know that x has to be less than 11. So let's plug in from the picture. So cosine, our reference angle is 60 degrees, and that's equal to adjacent, which is x, over hypotenuse, which is 11. Make the left side a fraction by putting a 1 under and cross multiply. 1 times x is x, and that's equal to cosine of 60 times 11. So cosine is 60 times 11, or you could write 11 times cosine of 60. So if I'm typing this in, I have to hit the reference angle first, which is 60, and then hit cosine times 11 equals, and I get exactly 5.5. I didn't have to round at all, so notice I use the equal sign that's not curved. So again, I hit 60 cosine times 11 equals, and that's 5.5. The second way you could have done this is used our setup for our 30, 60, 90 degree special right triangles. And again, how did we know it was 30, 60, 90? You have your 90 degree angle, that box, the 60 is there, and this would be 30 using triangle sum theorem. So our setup for 30, 60, 90s, we made our chart. We wrote 30, 60, 90 to represent the angles. 1, root 3, 2 were the original side lengths of the triangle, and then this final row we write from our picture. So what is directly across a 30 degree angle? There's an x there. What's across the 60? Nothing's there, so I'm just going to leave that blank. You could put a variable if you wanted to, but we don't need to solve for that variable, so I'm just going to leave that middle column blank. And then across the 90, the hypotenuse is 11. From here, we look at which column has just numbers, so we could find the scale factor, and that would be this third column. So trying to find our scale factor, we are saying 2 times what number would get us a new side length of 11. So again, technically you're just taking 11 and dividing it by 2, or if you want to write an equation, you're saying 2 times what dilation gives me a value of 11. So the opposite of multiplying by 2 would be dividing by 2. And if you turn this to a decimal, 11 divided by 2 is 5.5. That's exactly the same answer that we got for the trig ratios using a different process. So we're multiplying all original side lengths by 5.5. And if you look, x is just 1 times the scale factor. So that would be 5.5. The exact same answer using the trig ratios.